When asked what won the war, General Eisenhower named three things: the bazooka, the jeep, and the Bailey Bridge. Two of those are American. One is British. And the British one might have mattered more than the other two combined. Because without bridges, you can't move tanks, trucks, artillery, or men across a single river in Europe. And between D-Day and VE Day, the Allies crossed hundreds of rivers. The Bailey Bridge was designed by one man, a British civil servant named Donald Bailey, who first sketched the idea on the back of an envelope. You've never heard of him. Sit with that for a second. The supreme commander of every Allied force in Europe, the man who orchestrated D-Day, who commanded the largest amphibious invasion in human history, looked at the full catalogue of Allied innovation and put a portable bridge in his top three. Not radar, not the proximity fuse, not the atomic bomb. A bridge. Designed by a civil servant from Rotherham who worked in a quiet research establishment on the Dorset coast. And Field Marshal Montgomery, the most celebrated and arguably the most difficult British commander of the war, a man not exactly famous for handing out compliments, said the Bailey Bridge made an immense contribution towards ending the war. He'd watched Royal Engineers erect them under fire, tear them down, truck them forward and erect them again at the next river. Over and over, North Africa through to Germany. So two of the war's biggest names praised the same invention by the same man, and still almost nobody knows his name. That's the story hiding in plain sight. To understand why a bridge mattered more than a bazooka, you need to look at a map. Between the beaches of Normandy and the heart of Berlin lay a continent stitched together by rivers: the Seine, the Meuse, the Rhine, the Elbe, and in Italy, the Rapido, the Garigliano, the Gari. Between those major waterways, hundreds of smaller rivers, canals, streams, and drainage channels. Every one of them a potential choke point where the entire Allied advance could grind to a halt. The Germans understood this perfectly. As they retreated, they demolished every bridge behind them, every stone arch, every steel span, every timber crossing, blown, burned, or dropped into the water. It was the simplest and most effective delaying tactic available. You don't need to defeat an army if you can strand it on the wrong side of a river. And here's the thing nobody talks about. Tanks cannot swim. A Sherman weighed 30 tons. A Churchill weighed 40. Artillery pieces, ammunition trucks, fuel tankers, supply columns, none of them float. The bazooka gave infantrymen the ability to kill tanks. Brilliant. But a bazooka sitting on the wrong side of the Rapido River is useless. The jeep gave armies unprecedented tactical mobility. Revolutionary. But a jeep idling at the water's edge while the bridge it needs lies in rubble at the bottom of the riverbed is going nowhere. Every weapon, every vehicle, every piece of equipment the Allies possessed was rendered impotent by 60 feet of flowing water. The problem of the war wasn't firepower. The Allies had overwhelming firepower. The problem was movement. And the solution to movement across water wasn't a weapon at all. Donald Coleman Bailey was born on the 15th of September 1901 in Rotherham, a steel town in the heart of South Yorkshire. He read engineering at the University of Sheffield, the steel capital of England, graduated in 1923 and entered the civil service. Not the army, not a research university, the civil service. A government employee with a desk, a pipe, and a modest salary. By the late 1930s, he was working at the Military Engineering Experimental Establishment, MEXE, in Christchurch on the Dorset coast. His colleagues knew him as the quiet man, who spent his spare time tinkering with model bridges. Small-scale truss designs he'd rearrange and reconfigure endlessly, testing different arrangements of the same basic components. It looked like a hobby. Nobody watching him fiddle with those little models could have known they were watching one of the war's most consequential inventions take shape between his fingers. Then, in 1940, he turned over an envelope and drew a bridge. Not a formal engineering proposal, not a detailed technical submission routed through proper channels. An envelope. And on the back, he outlined a modular panel system. One standardized steel truss panel, identical in every instance. Combinable in different configurations to create bridges of varying strength and span. The genius wasn't in the materials, ordinary steel, wasn't in the manufacturing, straightforward factory production. The genius was in the concept itself. And the concept is so elegant it fits in a single sentence. One component, infinite arrangements. Think of Lego, one basic brick shape. From that shape you can build a wall, a tower, a house, a cathedral. The Bailey Bridge worked on exactly this principle. The fundamental unit was a rectangular lattice of welded steel, a standard truss panel that a small team of men could lift and carry by hand. Every panel was identical to every other panel. Need a quick crossing for infantry and light vehicles? One row of panels on each side. Need to carry a heavier tank? Bolt a second panel alongside the first. Need to span a wider gap? Stack them on top of each other. Need to do both? Add more panels in both directions. The soldiers didn't need new parts. They just needed more of the same panel. No special components, no custom manufacturing. One panel, one factory process, one component shipped to every theatre of the war. The soldiers in the field decided what to build with them. But here's where the visual story really comes alive. Picture a riverbank. The far side was enemy territory until recently. The existing bridge is a tangle of blown concrete and twisted steel in the water below. A convoy of trucks pulls up, carrying flat-packed steel panels. 40 men dismount. No cranes arrive, no heavy machinery rumbles forward, just men, wrenches, and those panels. The crew assembles the bridge on the near bank, on a set of steel rollers, building it outward panel by panel. Each panel slots into the next, using steel pins that drop into pre-drilled holes and are secured with bolts. The tools required are hand tools, nothing more sophisticated than a wrench and a hammer. As the bridge grows longer, it extends out over the gap, cantilevered over the water on the rollers, counterbalanced by its own weight on the near side to prevent it tipping forward into the river. When the nose touches down on the far bank, the rollers are removed. The bridge settles onto its bearings, decking is laid, and it's open. Tanks roll across. The entire process, from trucks arriving to 40-ton tanks driving over water, could take as little as 3 hours. And when the advance moved on, the whole process reversed. Disassembled, loaded onto trucks, driven to the next river, rebuilt. A finite number of bridge sets supporting an infinite number of crossings, leapfrogging forward with the army. Everything about the design answered the questions that actually mattered in a war. What can soldiers carry? What tools do they already have? How fast does this need to happen? Every answer pointed back to that envelope. There were skeptics, of course. The military establishment, as military establishments tend to do, harboured skepticism about a solution that looked too easy. The Inglis Bridge, the Army's existing portable design, heavy and cumbersome, had its institutional defenders. Competing designs circled. But on 1st May 1941, a full-scale prototype was erected over Mother Silla's Channel at Stanpit Marshes near the Mexi facility. It held. That prototype is still standing today, more than 80 years later. A quiet monument in a Dorset marshland that most people walk past without a second glance. By late 1941, the War Office had approved mass production. British factories began manufacturing panels by the tens of thousands. By war's end, roughly 700,000 panels had been produced, 490,000 tons of steel. The envelope sketch had become an industrial enterprise of staggering scale. And then the bridge went to war. The Bailey Bridge's baptism of fire came at one of the most brutal engagements of the entire conflict. And it's here that the story transforms from engineering appreciation into something you can feel in your chest. The four battles of Monte Cassino raged from January to May 1944, as Allied forces tried to smash through the German Gustav Line and open the road to Rome. The Gustav Line ran across the full width of the Italian peninsula, anchored by the ancient Benedictine monastery perched on the heights above, defended by some of the finest troops in the German army. Between the Allies and the monastery lay a series of river obstacles, the Garigliano, the Rapido, the Gari, and every bridge across every one of them had been demolished. The only way forward was to build new crossings. Under direct enemy observation, under artillery fire, under conditions that were, by any rational assessment, close to suicidal. The Rapido River became the crucible. It wasn't especially wide, 60 to 80 feet in places, but that was almost worse, because the narrowness meant the German positions on the high ground above were close, dangerously close. Every engineer working on that riverbank was visible to enemy observers and within range of artillery, mortars, and machine guns. The Rapido wasn't just a river. It was a shooting gallery with water at the bottom. During Operation Diadem, the final Allied assault that would break the Gustav Line, sappers of the Royal Engineers began construction of what was designated Amazon Bridge on the night of 12th May 1944. An 80-foot Class 30 Bailey Bridge spanning the Rapido. And every single panel had to be carried, positioned, and pinned into place while the Germans did everything they could to kill the men holding the wrenches. Hold that image, because this is the heart of the whole story. Men carrying prefabricated steel panels across open ground in the darkness. The flash and concussion of artillery shells impacting around them. Shrapnel whining through the air, the earth erupting in geysers of mud and stone, the shouts of wounded men being dragged clear of the construction site, and still the panels going up, pin by pin, bolt by bolt. When a section was hit and damaged by shell fire, it was pulled out and replaced with a fresh panel. That's the beauty of the modular system in its most grim application. You don't repair a damaged section, you swap it. Identical parts. The bridge didn't care which particular panel held the weight. When men fell, others stepped forward and took their positions. There was no option to pause, no option to wait for the shelling to stop. The shelling wasn't going to stop. These weren't infantrymen trained for close-quarters combat. They were sappers, engineers. Men whose primary skill was construction, who found themselves performing precise technical work, aligning pins, tightening bolts, leveling bearings in the middle of a killing ground. They carried wrenches, not rifles. Their job was to build. They built. Amazon Bridge was completed. Allied armour rolled across the Rapido and into the fight for Cassino. And it wasn't an isolated incident. Throughout all four battles, Bailey bridges went up across the Garigliano and Gari rivers under similarly appalling conditions. Bridges were hit, damaged, rebuilt. Hit again, damaged again, rebuilt again. The casualty rates among the bridging units at Cassino were devastating. But what those engineers achieved wasn't merely courageous, it was operationally decisive. Without those bridges, the tanks that ultimately broke the Gustav Line couldn't have crossed the rivers. The infantry alone couldn't have done it. Artillery couldn't have been brought forward. Supplies couldn't have reached the front. The envelope sketch had met its most savage test, and it held. Monte Cassino was the dramatic proving ground, but the Bailey Bridges War was only beginning. After D-Day on June 6, 1944, the Allied breakout from the Normandy beaches required crossing dozens of waterways as forces pushed inland through the bocage country of northern France. The Germans had destroyed bridges with their customary efficiency. Bailey bridges replaced them, often within hours of the demolition being discovered. As the advance accelerated through summer, the Seine, a major strategic obstacle, was crossed using Bailey bridges, carrying entire armoured divisions pouring eastward toward Paris and beyond. Every time you see archival footage of Allied tanks rolling through a liberated French town, those tanks almost certainly crossed at least one Bailey bridge to get there, probably several. The liberation of France ran on steel panels and pin joints. And then came the climax. March 1945. The Rhine. Germany's last great natural defensive barrier. One of Europe's mightiest rivers, wide, deep, fast-flowing, and nothing like the Rapido. The Rapido had been 60 to 80 feet across. The Rhine was one of Europe's great rivers, on a completely different scale. This wasn't a problem you solved with a standard Bailey bridge pushed out on rollers from one bank. This required something else entirely. Operation Plunder, the assault crossing of the Rhine, was the largest river crossing operation in military history. The Germans had destroyed every bridge along the river's entire length. The crossing required airborne drops, amphibious assaults, and, inevitably, decisively, the rapid construction of bridges to carry the heavy forces that would exploit the bridgehead and pour into the German heartland. Royal Engineers and American combat engineers worked around the clock. Within hours of the initial assault crossings, the first Bailey bridges were taking shape across the Rhine. Within days, armoured columns were rolling across into Germany. The longest Bailey bridge of the entire war was built during this campaign, approximately 558 metres, over a third of a mile of floating steel, a fully floating pontoon-supported structure built around the clock, carrying an unbroken stream of tanks, trucks and artillery into the collapsing heart of the Third Reich. Every hour that bridge wasn't finished was an hour the advance couldn't exploit its momentum. The engineering teams who built it understood that, and they built accordingly. Beyond Europe, Bailey bridges served in a theatre so different it might as well have been a different war. In Burma, British and Commonwealth forces under General William Slim fought the Japanese across some of the most unforgiving terrain on earth. This wasn't the open river-plain geography of northern France or the Italian valleys. This was jungle. Rivers, gorges and jungle ravines presented constant obstacles, and the Bailey Bridge's portability, the ability to carry it forward on trucks over terrible roads and assemble it without cranes, made it indispensable. No cranes in the jungle. No heavy equipment on those roads, just the panels, the pins, the wrenches and the men. The Bailey Bridge's human-scale components, its independence from machinery, that wasn't just convenient in Burma, it was the only option. Nothing else could have got there. British and Commonwealth forces used Bailey bridges to maintain supply lines and advance routes across terrain that should have been impassable to mechanised forces. The bridge that was born on an envelope in Dorset proved itself equally in the rivers, gorges and jungle ravines of Burma and the rubble of the Rapido. Over the course of the entire war, more than 3,000 Bailey bridges were constructed by Allied forces. 3,000. North Africa, Sicily, Italy, France, Belgium, Holland, Germany, Burma. Every theatre, every front. Wherever the Allies fought, wherever they advanced, wherever they hit water or a gap or a demolished crossing, the same answer appeared on the back of the same trucks. 3,000 times. The strategic arithmetic is simple and overwhelming. Between D-Day and VE Day alone, the advance across Western Europe required crossing hundreds of waterways. Every one was a potential full stop. One demolished bridge could hold up an entire armoured division. A single unbridged river could delay the liberation of a city. The Bailey Bridge eliminated that vulnerability. Not once, not occasionally, systematically, repeatedly, across every front, 3,000 times. It was the infrastructure of liberation itself. And every single one of those bridges, every panel, every pin, every configuration, traced back to that sketch on the back of an envelope, drawn by a quiet civil servant from Rotherham. So what happened to Donald Bailey? He received some recognition. He was awarded the Order of the British Empire, knighted in 1946, Sir Donald Bailey. But that's where it stopped. No major film, no dramatisation, no cultural monument embedding his name in the national consciousness. He described his work as just a job. He was, by every account, a quiet and unassuming man, the kind of person who'd rather tinker with a model bridge than give a speech about the one he'd already designed that changed history. He lived quietly, worked on, and died on May 5, 1985, at the age of 83. The man who made the liberation of Europe physically possible, gone with barely a whisper in the public record. Compare that to Barnes Wallis, the bouncing bomb, the dam busters. He's been portrayed in a major feature film. Ask any reasonably educated Briton to name a great British engineer of the Second World War, and they will almost certainly say Barnes Wallis. His name is synonymous with British wartime genius. Bailey designed a bridge that crossed every river between North Africa and Berlin, 3,000 times, under fire, built by hand. And you'd never heard his name until today. There's something deeply unfair about how fame works in wartime. Weapon makers get remembered. The people who solve the boring logistical problems, how do we actually move our forces from here to there, disappear from the story. As if the ability to cross a river is somehow less impressive than the ability to destroy a tank. Bailey didn't chase fame. Fame didn't find him. But the record should be corrected. When Eisenhower ranked the Bailey Bridge alongside the bazooka and the jeep as the innovations that won the war, he was making a statement that most people have never fully absorbed. Two of those are American icons. The bazooka, the weapon that gave infantry a fighting chance against armour. The jeep, the vehicle that gave armies unmatched mobility across any terrain. Both earned their place on that list. But the third item, the British one, designed not by a weapons laboratory or a team of military engineers, but by one civil servant with a pipe and an envelope. The Bailey Bridge didn't kill anyone. It didn't explode or fire or detonate. It just sat there, steady and reliable, holding 40-ton tanks above moving water while the war rolled across it. 3,000 bridges, every major river crossing from Italy to the Rhine, 700,000 panels, 490,000 tons of steel, assembled by 40 men with wrenches in 3 hours flat. Assembled under shellfire at Monte Cassino while sappers died putting in the pins. Stretched across the Rhine in a floating chain 558 metres long. carried through the jungles of Burma on trucks over terrible roads, built and torn down and built again, leapfrogging forward river by river by river, until there were no more rivers left to cross. And Bailey bridges are still in use today, deployed by militaries and disaster relief operations around the world. The same fundamental design, more than 80 years after a man in Christchurch turned over an envelope and changed the course of the war. Donald Bailey made the liberation of Europe physically possible. His name should be as famous as Barnes Wallis.
Now you'll remember it.
Subscribe for more stories like this one.